Hello friends, my name is Dr. Sachin Borse. I am Professor and Coordinator International Relations, Imperial College of Engineering and Research, Pune, India. Today I will discuss the dimensionless number in the fluid mechanics. So this topic is in connection with the dimensionless analysis. So before going to the dimensionless numbers, let us see what are the forces that exist in the fluid mechanics. So I can categorize the forces commonly exist and special forces. So many derivations or the proof we use the three forces. Can you tell me that forces? That are viscous force, pressure force and gravity force. Other forces are inertia force, surface tension force and elastic force. Let us see one by one these forces. Viscous force denoted by Fv. So this is the force because of viscosity. We know that viscosity is the internal resistance to the flow. So this viscosity causes the shear stress, and when shear stress acts on this area, it becomes the shear force. So this shear force, we'll call it as a viscous force. So shear stress into the area will be our viscous force. Now shear stress tau is given by Newton's law of viscosity. It is mu du by dy. Now as it is based on dimensional analysis, instead of du we will write velocity v, and instead of dy we will write L. L is the length scale and v is the velocity scale, and instead of area we will write length square. Okay, so it is related to the dimensions. We are maintaining the dimensions. So after simplifying we will get the viscous force as mu vr. So we got viscous force. This is because of viscosity. Now I'll move to the next force, that is the pressure force indicated by Fp. So this is the force because of the pressure, or we can say pressure difference. Okay, so this pressure when acting on the area, it gives the pressure force. So pressure difference into the area will be the pressure force. So del P, pressure difference into the area we are representing the length square. Okay, so that is our pressure force. Now we'll move to the next force, that is the gravity force. It is indicated by Fg. So it is because of the weight of the fluid element. So how we find the weight? We multiply the mass with the g. G is the acceleration due to gravity. So Fg is mass into the acceleration due to gravity. So m into g is the gravity force. So how we find the mass? Volume into density. Volume is what? Multiplication of length, breadth and height. So here is the length scale. So L cube, we'll take the L cube rho g. So that is the gravity force. Now we'll move to the force. Next force is inertia force. This is force because of it's the multiplication of mass into acceleration, that is called as inertia force. Okay, so mass into acceleration, or we can say deceleration. So that will be the inertia force. So mass into acceleration. Similarly, mass is volume to density. Volume is the length cube into density, and acceleration is velocity by time. Now we'll divide on the right hand side velocity and divided by LT. We know velocity is equal length divided by time. So by simplifying this, we'll get the inertia force as rho L square V square. We'll get the after simplifying this inertia force as rho L square V square. That is the inertia force. So inertia force depends on the square of velocity and the area, that is the L square. Now move to the next force, that is surface tension force. It is because of surface tension. It is a multiplication of the surface tension coefficient and the length of the linear element of the area to which force is perpendicular. So surface tension force will be sigma, surface tension coefficient, and the length. Now we will move to the last force, that is elastic force. It is because of compressibility of the fluid in the flow of the fluid. So it is elastic stress into the area. So elastic force will be the E into the A, where E is the bulk modulus of the elasticity. Now from these forces will form the different dimensionless numbers. Will form the Reynolds number, Froude number, Weber number, Euler number, Mach number. Now I'll move to the first number called as Reynolds number. Reynolds number is very important in the fluid mechanics and heat transfer. It is the ratio of inertial force to the viscous force. So Reynolds number is the Fi by Fv. So write down the Fi inertial force, rho L square V square divided by the viscous force mu Vl. So Reynolds number will be rho V L by mu. L is what? The length scale. So generally in the length scale we write the dH. dH is the hydraulic diameter. How the hydraulic diameter is given? 4 times area divided by the perimeter. So for the circular pipe, dH is the diameter. For other cross section of the duct like rectangular, we have to use this formula to find the hydraulic diameter. Reynolds number plays very important role in deciding whether the flow is laminar or turbulent. If the Reynolds number is less than 2300 inside the pipe or tube, it is the laminar flow. If the Reynolds number is greater than 4000, it is the turbulent. In between this 2300 to 4000, it is in transition. So it helps us to decide whether the flow is laminar or turbulent. Froude number, it is denoted by Fr. It is so it helps us to decide whether the flow is laminar or turbulent. Froude number, it is denoted by Fr. It is the square root of inertial force to the gravity force. Write down the inertial force, rho L square V square divided by gravity force, rho L cube G. So we get the Froude number as V divided by square root of GL. Froude number is relevant in the fluid dynamics problem where gravitational force of the fluid is important force. For example, flow in the spillways, weirs, channel flows, rivers, and in the ship design. So where the gravity force is important, there we use the Froude number, especially in the civil engineering. Now I'll move to the third dimensionless number, Weber number, which is denoted by WE. It is the square root of inertial force and surface tension force. So you write down rho L square V square, that is the inertial force. Then now write down the surface tension force, that is a sigma L. After simplifying, we get W is equals to V by square root of sigma by rho L, where this Weber number is used. It is used in the phenomenon where surface tension force is dominant, like the flow of the blood in the veins, arteries, atomization of the liquids, capillary flow of the water in the soil, and the flow in the microchannel. So this is about the Weber number. Now we'll move to the Euler number, indicated by EU. It is the square root of the ratio of inertial force to the pressure force. Right? Inertial force rho L square V square divided by pressure force del P into the L square. By simplifying, you get the Euler number as V divided by square root of del P by rho. Euler number is significant in the phenomenon where pressure gradient exists, such as flow through the pipes, water hammer pressure in the penstock. So in case of water hammer and flow through the pipe, this Euler number EU is important. Now we'll move to the next dimensionless number. So it is Mach number, denoted by generally capital M. It is the square root of inertial force divided by elastic force. So if you write M is equals to square root of rho L square V square divided by EA, elastic force. Simplifying, we get M is equals to V by square root of E by rho. The square root of E by rho is called as A. It is the velocity of the sound in the fluid medium. So simple formula for Mach number is velocity of the flow divided by velocity of the sound at the same temperature condition in the same fluid. What is the use of this Mach number? The use of the Mach number is to see whether the compressible effects are there in the fluid. Normally, the flow of the air in the mechanical engineering application is not compressible, like flow of the air in AC duct. Okay, flow of the air on the car, it is not compressible. Why? Because Mach number for the flow of the car is less than 0.3, and if the Mach number is less than 0.3, the flow is called as subsonic. If the Mach number is greater than 0.3, it is called as compressible, like the flow of the aeroplane, flow of the rocket are the examples of compressible flow. Similarly, it is also used to define whether the flow is supersonic or subsonic. If m is less than 1, it is called as subsonic, and if m is greater than 1, it is called as supersonic. It just makes the classification as the design of the aeroplanes below Mach number 1 is different, and design of the aeroplanes above Mach number 1 is different. So it helps us to classify the flow. So these all dimensionless numbers are very important, especially in the PG program or even in the UG programs. For the research, it is very important. Thank you for watching this video. Hope you like this. Give your